Yep.
Okay.
Well, if you draw a line, I'll draw it straight to that point there, right?
Yep.
That's stationary. That's stationary, right? All the rest is moving, right?
Yeah.
All the rest is moving. And I add weight there, and it stays there until it gets to there, right?
Yep.
So every time one of those hands on my clock reaches 2 o'clock, right, there's a weight put on it, right?
That's
and
right.
It stays on there until it reaches 4 o'clock. And it's left there. And when it's left there, gravity just lets it roll all the way back to the centre.
Mm-hmm.
When it gets to the centre, as that circle is half the size of the outside circle, right? It starts to pick that same ball up and move it up there. And because it never exceeds half the distance of that, 2 balls could be there at the same time, which only equal 1 here.
That's right.
And you never have any less than 2 balls on this at a time. As you've got 1 going on at 2, when it gets to 3, another one's going on. So, at the worst scenario, you've got 1 ball almost about to leave there. You've got another ball that's on there, and you've got 1 ball almost
just about
going on. Plus you create momentum and power in the wheel itself.
Yeah.
Once the momentum of the wheel picks up, it in itself will pick a ball up and take it from the bottom to the top. Right?
Yep.
So by constantly adding the weight out there, you will always exceed what weight you have here.
That's right, because it's in a smaller area.
Now if you draw a line through there and through there, right, and you use a factor of 10, right, you would have 0, 5 and 10, right?
Yeah.
Now if you calibrated that up, right, you can imagine you start calibrating up here. That ball that's on here at 7 o'clock, we'll call 7 o'clock, he doesn't even know he's there yet because he's only moved out a fraction.
Yeah.
This ball that's all the way back up here at 11, he's lost all his power. He's just pleased to get off again. Right?
Yeah.
These couple out here, right, they're the ones that are putting a little bit of power on it. So but no matter how you calibrate it out, right, you will always exceed probably about 20% more weight out here than you will here.
So the force that's pushing down on the outer side, there's not as much force on the inside to counteract it.
That's right. And by instead of trying to pull it all the way up here to add the weight, you add the weight out here where you've got momentum, where you've got a leverage.
Yeah.
By adding weight up here, it does nothing until it gets out here, right? Yep. But by adding weight out there, it's like having a crowbar and shifting a rock,
Is there anything critical, Chaz, to the sizes and distances and ratios?
No, it doesn't make it, but it's important that when you make a thing like this, you've got to allow enough time for that ball to move from there into there, right? Into that space.
So
now, if you try and rotate it too fast, right? If you try and go too fast, the balls lose their weight.
Yep.
They become airborne.
Oh, okay.
It's like anything. They become centrifugally thrown out, right? And it won't work. So I would imagine that a wheel like that over there that you filmed before would never exceed any more than 4 or 5 RPM. Now that's at 5 RPM, right? At 5 RPM, right? That's what's 5 12s to 60, isn't it? That would be allowing 1 second for that to get to there, for that to get to there. 1 second, 1 and 2. Now I would say that would be a pretty fair, because if you come under that, you're asking the mechanism to do too much too quick. And to ask it to do it just using gravity alone is asking a bit, right? If it was mechanically operated, like valves, like pistons or points in a car, that's a wholly different thing. But to operate this just by gravity, you cannot expect it to go too fast. So to create the power, you build a wheel big enough and strong enough and heavy enough. And once it starts rolling... It's like the tyre rolling down the street. If it was off a big truck and you stood in front of it, it'd run over you. Right? Yep. If it was just off my little Datsun outside, I might get a bit of sponsorship for mentioning that word. No, only joking. But, you'd stop it with one hand, wouldn't you? Yeah. That's the same thing with the wheel. You build a wheel, but, things like that have got to be... When you're expecting everything to work without any mechanical devices at all, no springs, no magnets, it's just purely working on gravity.
And with the right engineering, you probably could engineer something that could do a few thousand RPM.
So just say, Chaz, you just say you were given some endorsement in that. What would you do to improve this system to make it how you wanted it, to optimise it?
Well,
you'd build what? You'd start with what?
Well, to start off with, you've got to build with a very substantial base, right? You have to have a base that's so rigid and so firm. You can't have any movement. You can't have any unnecessary movement. Everything, the balls are no problem. They'll always roll downhill. Yeah. That's no secret with gravity. It'll always roll that ball downhill. And once you put the ball on the outside of that wheel, it'll always push the wheel down, which in turn turns it around, right? But it's the mechanism in between. To take the ball from A and put it to B without using any energy from the machine. And to take it from B to C without using any energy. Because every time you falter it's using a little bit of energy off the momentum of the wheel. And once you do that, then it becomes unstable. It starts to roll, as you can see that one, it starts to sway. So the first thing is the whole inside of that, the principle would remain the same. But the whole inside has got to be built out of materials and heavy enough so as, it's like leaning on that. It's not going to move, it's not going to move. Whereas that one, I'm afraid, just by transferring the weight of the balls going around and moving from one side to another, starts movement. And as you can see by those balls, they start to roll backwards and forwards where they should be sitting nice and stable. Now, there's engineers and professors around the world that could improve on this enormously. But the principle is so simple. Yeah. And why this hasn't been done 100 years ago, I don't know.
All the corporate suppression and that, they're scared of free power.
But they tell me that there's millions of dollars on offer for someone that can produce perpetual motion. I read that on the internet one night. Yeah. Some firm in America will give you 10 million or something like that. I don't know what they said, but I don't take much notice of that. No. Because 90% of it, you can put that there too, 90% of it is garbage. They're not interested in giving $1 away, let alone $1 million. But when I come up with this theory, by spending $50 and ringing up a company one day and asking them if they could get me a ball bearing, right? Mm-hmm. Everybody's telling you about that? I asked them if they could get me a ball bearing, and they said, we can get you a 50 mil ball bearing. I said, 50 mil? I said, what do they use it for? And there was a hesitation on the phone, and he said, well, it's a ball bearing. I said,
they'd probably use it for...
Anyway, so I said, can you get me one? He said, just a minute. And he got back to me and he said, yes. He said, it'll cost you $50, Chas. I said, all right, get it for me. He said, I'll ring you when it's in. So I went over to pick it up and he said, it weighs half a kilogram. Here, catch it. No, it won't land on your tail. It weighs half a kilogram. It's exactly 50 mil across, right? Now, he got that for me and I come home with it and I started playing with that ball, right? I had a theory that if you roll a ball, right, far enough, right, and it's got to be a round object, right? Now what I done, I used aluminium like this, right? And up there in my lounge room, I had all sorts of devices set up. As a matter of fact, and I used to set that up. I might set that up, say, 4 inches above the floor, for argument's sake, and see how far it had to roll before it had enough weight and pressure up, speed up, to lift it up 4 inches. Now, all of that's supposed to be impossible. But it's not impossible.